Hello, you're welcome to my channel. Now right here in this video, we'll be solving logarithm of I to any base b. Okay, where a, b could be any base provided that b is greater than 0. Okay, and now we have this. Ooh. How do we go about that? Well, logarithm of I to any base b, let's say it is equal to some value x, right? It is equal to x, where the x right here is an unknown. And now, from log property, it will be given that b to the power x is equal to I, like this, alright? Very nice. And b to the power x is equal to I. Now, I want you to know that I is the same thing as saying cosine pi plus I sine, I can call it cosine pi over 2 plus I sine pi over 2. Like this, alright? Where the argument right here is just 90 degrees, that's pi over 2, and the modulo is going to be 1. This is how to represent I in polar form. But if we have it to be 90 degrees, okay, we turn it 360 degrees, we have 90 degrees somewhere here, then 360 degrees turn is still going to take us to that point, 90 degrees, and again and again and again. So I can go ahead and add 2n pi, where 2n is a 360 degrees and n is just a constant multiple belonging to the set of integers, okay, just a whole number. So it is in such a way that if we add 2n pi to the angle pi over 2, this is pi over 2, 90 degrees, you add 2n pi, that's 360 degrees, you're going to get back to that point. If you add it 2 times, you still get back to that point, 3 times, 4 times. So those number of times depends on the n. So this is the formula right here. So this can be rewritten as cosine of pi over 2 plus 2n pi, like this, alright, plus I sine pi over 2 plus 2n pi, again, like this. Okay, and having that, we can go ahead and represent this in the Euler form, and we're going to have that I is equal to, in Euler form, well, we just write E, which is the Euler's constant, and to the power of I times the angle or the argument. So here we're just going to have pi over 2 plus 2n pi. And besides, the coefficient of this E is actually the modulo, and the modulo is said to be R equal to square root of the real part, which is 0 squared, this is just 0 plus I. Okay, and the imaginary part, which is 1 is here, and that's 1 squared. So 1 squared is just 1, and square root of 1 is just 1. So the constant multiple there is not going to be same because it's just 1. Okay, so I can be written as this, alright? So in place of I right here, I can write all of this for it. So I'm going to have b to the x power is equals to, so in place of I, I'm going to write the whole of this. I'm going to have e to the I, open bracket of pi over 2 plus 2n pi, like that. Alright? Okay, very nice. Well, from here, if we go ahead and take the ln on both sides, we're going to get our x, alright? Remember, our aim is to find x, where x is log of I to base b. Okay, so we take the ln on both sides, natural logarithm on both sides, ln and ln. So here we just write it to be b to the x power, and it's equals to, right here we just have it to be e to the I times the whole of this, pi over 2 plus 2 and pi, like that, alright? Very nice. Well, here we just have it to be x times ln b. So we have it to be x times ln b. Ln b is equals to, ln I is going to get to 1. Then we just have the power here. We're going to go back from your log property. So we're going to have it to be I times the whole of that, pi over 2 plus 2n pi. Okay, let me take it up from here. Oh. Very nice. Okay, so from here we can just say let's divide ln b on both sides so that we make x subject of formula. We're going to have x is equal to, well, x is going to be equal to all of these divided by ln b. That is I times pi over 2 plus 2n pi, okay, divided by ln b. And this is what you get as the answer. So look at this is shown. Let me just take it up. Okay. So this is the value of x. So for your known base b, then we're going to have it that I is times pi over 2 plus 2n pi divided by ln b, where b is just your base and n belongs to the set of integers. Okay, so if you have a particular question, let's say ln of I, that is log to base e. Okay, log of I to base e. That is synonym for ln. Okay, log of I to base e. Then we are sure that this base is e, so we can quickly apply this formula and say that it is equal to, well, here we just have it to be I times, at the top we just have pi over 2 plus 2n pi, like this, divided by ln b, where b was the base, so ln e, and we have it to be ln e. Well, ln e is the same thing as saying what? 1. So everything here will just become I pi over 2 plus 2n pi. And this is the result for ln I, that's natural logarithm of I. But this is the general formula that we make use of to solve for the logarithm of I to any base b. Okay, thanks for watching this video and please subscribe to this channel.